Okay, hello everyone. Today we're going to talk about dividing radical binomials. And this is the last new content before we have the next test. Again, we're dividing this bottom term, this denominator, is a binomial. It has two terms. And there's radicals in there. So we got to learn how to divide by that. Today's objective, to divide radical binomials, and the key really is to rationalize the denominator. And we've done that if there's just a monomial in the denominator. We've done that, and we're going to use a very similar technique. In today's essential question, how do we divide and rationalize radical binomials? Sort of, how do we rationalize radical fractions, or fractions with radicals expressions in there? And kind of see what we're doing right here. The square root of a plus b times the square root of a minus b, square root of b. All right, look, let's go back and just a little review. Remember when we factored a quadratic expression that was the difference between two squares? Like this here, a squared minus b squared. Remember that? What we got was called the conjugate pair. A plus b times a minus b. Here's some examples here. All right. And if you remember when we multiplied the conjugate pair, we multiplied a conjugate times its pair, the middle term is eliminated. The middle term, that's 6x here in this particular example, is eliminated. That's why we ended up with a quadratic with just two terms. That's the only way we can have a quadratic with just two terms, is by having the middle term eliminated. Again, conjugates. Guys, the conjugate of a plus b is simply a minus b. And the conjugate of a minus b is simply a plus b. So the conjugate of 5 plus the square root of 3 is 5 minus the square root of 3. Guys, and we're going to use these conjugates to rationalize the denominator when the denominator is a binomial radical, a two-termed expression involving a square root. And the reason we're doing this, guys, we use conjugates to rationalize the denominator because multiplying by the conjugate eliminates the middle radical term. That's why we do it. As an example, this denominator has a radical in it. We want to get rid of it. So 4 minus the square root of 3, just multiply it times 4 plus the square root of 3. But we need to multiply this whole thing times 1. So we multiply it by this fraction, 4 plus the square root of 3 over 4 plus the square root of 3. All right? And so when we do that, again, this middle term disappears. You see the plus 4 times the square root of 3 and the minus 4 times the square root of 3 right here. It goes away. We just get 16 minus 3, 13 in the denominator, and that's what you want. Then just combine like terms in the numerator. You can have a radical in the numerator. Just get rid of it in the denominator. At example 2, there's two radicals here. Square root of 2 plus the square root of 3. Again, just multiply the top and the bottom times the square root of 2 minus the square root of 3. And when we do that, the bottom just becomes 2 minus 3, or negative 1. When you combine terms here, the top is the square root of 2 minus the square root of 3. See, we get the square root of 4 here and the square root of 9 here. And that's why we get the 2 minus 3. Again, this negative 1 on the bottom, just take it up top. Just change the sign of the top two terms. Okay, so here's another example. 1 plus the square root of 3 on the bottom. So multiply the top and the bottom times 1 minus the square root of 3. When you do that again, 1 squared is 1. The square root of 3 squared is 3. So the bottom just becomes 1 minus 3, which is negative 2. All right? The top, just distribute that square root of 2 times 1, and the square root of 2 times negative 3, so we got negative the square root of 6, and negative square root of 2 in front. And that negative on the bottom, just bring it up top by changing the sign of the top two terms. You can do that. So instead of negative 2 on the bottom, just bring it up top. So the top becomes positive square root of 6 and negative square root of 2. All right, here's another example. Again, the denominator is square root of 5 minus square root of 3. So multiply the top and the bottom by the conjugate of that. Square root of 5 plus square root of 3. All right, you get kind of a long number at the top, a long answer at the top. All right, when you do not have like radicals, and that happens sometimes when you have a lot of radicals up here that are not the same. You can't combine them. Just leave. You have 4 terms right here in the numerator. Leave them alone. Just leave all 4 terms there. But the denominator, those will start to eliminate because the square roots will disappear. This becomes 5 minus 3, just 2 on the bottom, okay? Our last example here, the square root of x minus the square root of y underneath, 2 variables. I'm going to multiply the top and the bottom here then by the square root of x plus the square root of y. And guys, that's the top, that's the numerator here, square root of x plus the square root of y. So I'm just squaring that. So if you go right to the bottom here, you get the x in the front and the y in the back. And the middle is 2 times the square root of xy, all right? Because there's 2 of them here, you're putting them together. But the bottom, the square root of xy is eliminated right here. That middle term is eliminated. You just get the square root of x squared, which is x, and the square root of y squared, which is y. It's kind of like the difference between 2 squares. That's why you have the x minus y in the bottom. All right, guys, that's it. Again, watch this video in class, and then we'll do the warm-up, okay? These are the 3 warm-up questions. And thanks for listening.